Hi to all. In this video, we are going to deal with construction and operation of synchronous machines. Okay, construction. A synchronous motor is a machine that operates at synchronous speed. What is synchronous speed? Synchronous speed is nothing but the speed of the rotor as well as the speed of the stator. If both the speeds are equal, then or synchronized, then that type of motors are called synchronous motors. Okay, speeds. The synchronous motor is a machine that operates at synchronous speed and converts electrical energy into mechanical energy. In the case of motor, which converts electrical energy into mechanical energy. In the case of generator, converts mechanical energy into electrical energy. Okay, so that we know. Okay, it is fundamentally an alternator operated as a motor. Like an alternator, a synchronous motor has the following parts. All the motors or generators having mainly two parts. One is stator, it's a static part. Another is rotor, it's a rotating part. Come to this one. Okay, stator, which houses three-phase armature winding in that slots of the stator core and receives power from a three-phase supply. Like all the motors, this motor also having two parts. One is stator and rotor. For the stator, we are receiving three-phase supply. Okay, we are applying supply to the stator of three-phase AC supply. Okay, second one, a rotor that has a set of salient poles excited by direct current to form alternate N and S poles. Okay, previously for the stator, we are giving a supply of AC voltage to the rotor. Here we are giving a supply of DC voltage. Okay, a rotor has set of silent poles excited by DC or direct current to form alternate N and S poles. The exciting coils are connected in series to two slip rings. Okay, and DC current is fed into the winding from an external exciter mounted on the rotor shaft. Okay, when we go for induction machines, we are not going to give any supply to the rotor parts. Only for the stator, we give the supply. Based on the supply of stator, induction machines will work. When we come for synchronous machines, we should apply a voltage for both stator as well as rotor. Okay, you can understand the difference between induction machine and synchronous machine. Okay, induction. Okay, supply connected winding from external mounted circuit. The stator is found from the same number of poles as the rotor poles. As a case of induction motors, the number of poles determines the synchronous speed of the motor. Okay, Ns is equal to 120 F by P, where F frequency of supply in hertz, P number of poles. An important drawback of a synchronous motor is that it's not self-starting and auxiliary means have to be used for starting it. When the case of induction motors, we are not going. It's a self-starting motor. When in the case of synchronous machines, it's not a self-starting motors. Operating principle. Okay, the facts that synchronous motors has no starting torque can be easily explained. Why it is a not self-starting motor? This that things we are going to see now. Okay, consider a three-phase synchronous motor having two rotor poles, NR and SR, rotor north pole and rotor south pole. Then the stator will also be found wound for two poles, stator north pole and stator south pole. Okay, the motor has direct voltage applied to the rotor winding, and three phase of AC supply is applied to the stator winding. So in the stator winding produces a rotating field which revolves round the stator at a synchronous speed. Ns is equal to 120 FIP. But in the case of rotor, we are giving the supply of direct current. Okay, that's when we give direct current supply, the north and south poles are excited by the supply voltage, which is stationary, and so long as rotor is not turning. Okay, thus we have a situation in that there is exists a pair of revolving armature poles. In this condition, there are two pairs of revolving armature poles are existed in that motor. One is north NS to SS, stator north pole to stator south pole, as well as rotor north pole to rotor south pole. Okay, in this diagram, see this diagram here, AB. There are two conditions. One is in anti-clockwise direction, another is clockwise direction. Okay, these things when we happen. Okay, when north pole of the when north pole of the stator as well as north pole of the rotor, if both the things are north poles, so what will happen? Automatically repels each other. So in this condition, it try to rotate in anti-clockwise direction from this diagram A. Okay, next come for second diagram. Here, when it's in a stator, it's a what we call rotating magnetic field. The magnetic field is a AC, so it continuously it changes. Okay, when the position of A and A to B, if north pole in stator and south pole in rotor, so it try to attract. That time the motor try to rotate in clockwise direction. Okay, in the previous case it tried to rotate in anti-clockwise direction. In the second case, it tried to rotate in clockwise direction. So then the rotor in one direction. After a period of half cycle, due to high inertia of the rotor, the motor fails to start. Hence, a synchronous motor has no self-starting torque. That's why a synchronous motor cannot start by itself, and it need a external source to start the motor. Thank you.